Imagination will often carry us to worlds that never were, but without it, we go nowhere. Nearly everything I am about to say is based upon imagination. Most of these will likely never be built, or even considered throughout all of the rest of human existence, much less our lifetimes. Nevertheless, such large structures can serve as an inspiration for the future and help push us to reach our goals. Today, we are going to be discussing megastructures. For reference, take the Great Wall of China or the Large Hadron Collider. These are considered some of the less ambitious megastructures and are some of the few that we have built. To begin, let us start with the more realistic megastructures, some of which have already entered early stages of research. For this stage, we will mainly focus on the space elevator. Many variations of space elevators exist, but the core concept of them is to serve as a vertical ascent system between the surface of the Earth and orbit, without the use of rockets. This would dramatically reduce the costs of sending things in space. There already has been basic research, from NASA to Japan to even Google. Unfortunately, many of them are still limited by the fact that the only material remotely strong enough and light enough currently discovered to support a space elevator are carbon nanotubes. And currently, not a single perfectly formed nanotube has been produced over a meter in length. There is, though fortunately, currently a very small scale space elevator being tested in the ISS by Japan as of September 2018. Next, we are going to jump up in scale to orbital sized structures. An orbital ring, a hypothetical structure originally conceived by Nikola Tesla, is a ring surrounding the planet such to make transportation to space and across the planet cheaper and more efficient. The basic idea behind the structure is to place a ring into low Earth orbit along the equator, such that it encompasses the planet. This would allow space elevators to be easily set up anywhere across the ring's path for easy transportation. Such a large system would obviously require an immense upfront cost and technological advances that we do not currently have. But if such a system did exist and were built, it would put the cost of transporting payloads into space down to about 5 cents per kilogram. O'Neill cylinders are a proposed design for outer space settlements. A colony would compose of 2 separate cylinders that rotate to simulate gravity using centrifugal force. Both would be rotating in opposite directions, one clockwise, the other counterclockwise, in order to minimize torque. On a classical O'Neill cylinder colony, each cylinder is 3 kilometers in radius and 30 kilometers long. This would house up to approximately 10 million people, about the population of North Carolina. Next, we are going to move to the more stellar scale structures. These structures are far beyond humanity's current capabilities, but are interesting nevertheless. We will begin with the Dyson swarm. This is a hypothetical structure that is composed of a large number of objects orbiting the Sun in a dense formation. These objects are usually solar collectors of some kind, in an attempt to take advantage of a star's immense energy output. This is also thought to be a possible indicator of Kardashev 2 civilizations, causing some natural phenomena to be improperly misattributed to aliens. The final megastructure we're going to cover is the Shakhdov thruster. This is a stellar propulsion system built using an enormous mirror or light sail. This would be built such that the acceleration of the object away from the star using radiation pressure would be the same as the gravitational attraction to the star. This would cause an asymmetry in radiation pressure being emanated, which would act as thrust, moving the star and the sail. This would allow the movement of stars on large timescales. This has been my final presentation for astronomy. My name is Devin Williams, and thank you for listening.